Let's answer this. This is going to be very, very easy. It says that we have to observe this figure and answer the following questions. Let's look at the first one. It's very simple. It says write the name of opposite ray of ray RP. Now this concept of opposite rays we have learned. We know what are opposite rays first of all. What are opposite rays? Two rays are said to be opposite if they have a common origin, right? And both the rays should lie on the same line in opposite direction. We know that. We are talking about opposite ray of ray RP. So let's first identify ray RP. So when we say ray RP, the origin is R. It starts from R and moves in the direction of P. So identify there. It is R and moving in the direction of P, right? So that is ray RP. We are saying that we want the ray opposite to RP, right? That means it has to lie on the same line, that we know, starting from R, moving in the opposite direction. That means it is nothing but ray RT. Yes, the same ray can also be called as ray RS. So we say ray RS or we say ray RT. It is one and the same. So we can name it as two different rays. One is ray RT, starting from R, moving in the direction of T. And on the same side, we have a point S. So we name it as ray RS. It's one and the same. Isn't that easy? Very, very, very simple, right? So that's based on the concepts which we have learned, and they're very simple. Let's look at the next one. It says write the intersection set of ray PQ and ray RP. Now this is interesting. We are talking about intersection. We are talking about the set concept which we have learned. Intersection union, we have learned that, right? When we say intersection, it's nothing but the common elements to both the set, right? So when we say ray PQ, identify that ray PQ starting from P, that's the origin, moving in the direction of Q. So we identified that, that is ray PQ. Okay, I'll just separate it for your understanding. And ray RP, now when we say ray RP, that means it starts from R, moves in the direction of P. So we identify that too. So we have it. So this is ray PQ, this is ray RQ. You're saying what is common to both? Now look here and tell me what is common to both. Yes, you're very correct. You're very, very clear. This is nothing but ray PQ which is common to both. You have ray PQ here, ray PQ here, isn't it? Observe very carefully. Yes, that means we are saying that the intersection set of ray PQ and ray RP is ray PQ. Was that easy? It's so simple, right? It's just a common element to both the sets. Then the next one, let's identify the next one, answer the next one. Write the union set. So this time we are going to write the union. Union is nothing but, if there are two sets, everything included, the common and the uncommon elements, everything together, what it forms is nothing but a union, right? Let's understand. So let's identify the two sets, which are the ray PQ. So it starts from P, moves in the direction of Q. We got that. Ray QR starts from Q, moves in the direction of R. Starts from Q, moves in the direction of R. Beautiful. What do you get? Ray PQ and ray QR, what does it form? Together it forms nothing but it forms a line. Which line? The entire line. Now you take any 2 points on the line and name it. So we name it as line QR, we name it as line PQ, right? We name it as line PS, anything. Any 2 points we take and we name the line. So what we get, the answer is nothing but adds the line. So take any 2 points, we have taken it as Q and R, so we can now answer it as line QR. Wasn't that easy? Very easy. There's nothing great here, right? So we understood. Let's look at the next one. This is going to be interesting. State the rays of which segment QR is a subset. What do you mean by that? That means we need to identify those rays where segment QR is a part of it. That means segment QR should belong to that ray. So let's identify. Well, let's look at first segment QR. That segment QR. Now segment QR, when we say, right, segment QR, once we say, we are talking about that. So one thing is very clear, from the endpoints we'll get ray, right? If we say, now observe, we take the endpoint as Q. Now everything moving that side, that ray, you can say QR, you call it as QT, you call it as QS, you call it as QP, it's one and the same. Now observe this ray QT, does it belong QR? Yes, it has segment QR. That means segment QR belongs to that. That means segment QR is a subset of that ray. So that ray can be named anything. From Q as the origin, moving towards T, moving towards S, moving towards R, moving towards P, you name it anything, right? That means we write it as ray QR, right? Anything. You name it as ray QP, ray QR, ray QS, ray QT. Doesn't matter. Simple. So is that the only ray which contains segment QR? No, we can have a different one. Observe, if you start from R and move this way, again, this ray, does it contain QR? Yes, it contains. What is that? It is nothing but segment RQ. So we got 2. Can we have more rays which contain segment QR? Yes, we can have. Suppose we start from T and move in the direction of Q. Look at this ray. Does this ray contain that segment QR? Yes, that means we say ray TQ is another ray. Now you'll say same way we can start from origin S and move in the direction of Q. You're very correct. So that means we get one more ray. Which one is that? Ray SQ. Beautiful. So these are the rays for which segment QR is a subset. That means segment QR belongs to this ray. Wasn't that easy? Very simple, right? Beautiful. Let's see the next one. Write the intersection set of ray SP and ray ST. Look at ray SP. That means the origin is S, moving in the direction of P. So starts from S, moving in the direction of P. ST, starting from S and moving in the direction of T. Beautiful. These two rays, when we say intersection, we are talking about common. What is common to both the rays? There's no segment, nothing, but there's only one thing which is common for both. From the name itself we understand what is common. Point. Which point? S. Beautiful. So that means the answer is point S. Was that easy? Very easy. Let's look at the next one. It says that write any two rays with common endpoint S. Now this is interesting. Two rays with common endpoint. Now when we talk about a ray, that endpoint which is nothing but that's called as a origin. So endpoint here refers to the origin. So we are saying we want two rays with a common origin S. That means one ray starting from S, moving in one direction. Let's say we take in the direction of T. So what is that? Ray ST. One more ray which starts from S, moves in the opposite direction. What is that? Ray SQ. Beautiful. So ray ST and ray SQ, this is nothing but, these are two rays which have a common origin, common endpoint, means common origin S. So simple. Very easy, right? Let's look at the next one. It's very interesting. It says that write the pair of opposite rays with common endpoint. Again, common endpoint refers to, it's nothing but the origin. That means we want opposite rays with a common origin R. It's simple. When we say talk about common origin, we know what is common origin. It's nothing but origin which is common to both, right? And when we say opposite rays, we know two rays are said to be opposite. If they have a common origin, they should lie on the same line and in opposite directions. Let's start from R. Let's say we continue and we say we consider a ray which moves in one direction to the direction of P, or you say to the direction of Q. Which one is that? Ray RQ, okay? Or we call it as ray RP. That is one ray. We want one more ray which starts from the same origin R and moves in the opposite direction on the same line. Which one is that? Ray RT. That means now we know the answer. It is ray RQ and ray RT. Was that easy? It's so very simple.